Like it won't be square root of 49, square root of 81, all of that. So it's going to be things that you have to break apart. I put all the squares and cubes and fours over here that we will need. So hopefully you don't have to keep flipping back into your notebook. Okay, so we just have a lot of different examples to work through today. We're going to do quite a few simplifying ones, and we'll do some adding, subtracting, and multiplying at the end. It should take the whole time, but it's not super short either. Okay, so if I give you something like square root of 8, you don't have a calculator, we want to break this apart and look for a perfect square inside of 8, like a factor. Can I take square root of 2? No, 4. And that's good though, because you still need 2, right? It's 2 times 4. Okay, so I'm just breaking 8 apart. What is the square root of 4? 2. So that comes on the outside. And this 2 stays on the inside. Okay, so I take the square root of this 4 is 2. It goes on the outside. The other 2 stays inside. That's what my second grade said that too. They're like, I was so bad at radicals. It's not that bad though. They felt good afterwards, so maybe you will feel the same. Okay, number 2, square root of 80. Square root of 80. So when you look at your perfect square list, I would try to find the biggest one just to make your life easier. Like 4 goes into it. 4 times what, 20? But what else might go in? Anyone know? Another perfect square? 8 times 10, but neither are perfect squares. So I know it's not 81. 64 go into it? No. 49? 36? 29? 16 times? Yes, 5. 16 times 5. Okay, I'm going to show you both ways though, because what if on the test you don't know that 16 times 5 is 80? I'm going to do it this way too. So let's say I do know 4 times 20. Okay, I'm going to do the short way first. What is the square root of 16? 4. So the 4 goes on the outside. The 5 stays on the inside. Okay, if you can't think of the greatest perfect square that goes into it, it's okay. You're just going to have a little more simplifying to do. So here, I take the square root of 4 is 2, and then I still have 20 on the inside. What perfect square is inside 20? 4. 4 times 5. Okay, so again, take the square root of 4, which is 2. When it comes to the outside, I multiply it. So it would be 2 times 2, or square root 5. So same answer. Because I don't want you to think that just because you can't figure out what number goes into it, you're not going to get the right answer. You can just break it down a little bit more. Okay, so if there's a number on the outside like this, and you bring a number outside with it, they get multiplied together. All right, number 3. 4 times the square root of 54. So the 4 just stays on the outside. 9 times 6. 9 times 6. So I take the square root of 9, which is 3, and I'll write it out here so you see what happens to it. So I took the square root of 9, which is 3, and then you just multiply the outside numbers together. So my answer is 12 square root 6. Okay, those 3 were square roots, so we'll do a cube root here. Let's do cube root of 24. So the mistake I see here is you'll go along, and you'll just be like, oh, 4 times 6, but 4 is a perfect square, and I'm not doing square roots, I'm doing cube roots. So you look at your second little column, which of course you'll have those memorized. 2 to the third is 8, 3 to the third is 27, it can't be 27. So 8 times what? 8 times 3. What's the cube root of 8? 2. So I put 2 on the outside. So 2 on the outside, and then the 3 stays on the inside. Cube root of 3. It's not horrible, right? Okay, 4th root of 32. times 2. Okay, be careful here. What's the fourth root of 16? 2, right, not the square root of 16. So fourth root of 16 is 2, and then the other 2 stays on the inside. So far so good? I'm going to throw some letters in now. Why? You know it never stays easy. Okay, number 6. Is everyone up to number 6 though? Because I don't want to go on. Okay. Number 6, square root 125, x 4, y 5. What's our little number right here? 2. Okay, so we're doing square root. So what's a perfect square inside 125? 5 times 25. Okay, what yesterday we did this. We took our exponent and we divided. So 4 divided by 2, that's going to come out even, right? The y though, because I have y to the 5th, that's not going to come out even. So I'm going to split the y up. So I'm going to leave the x4. And I'm going to split the y up into y4, y1. And you'll get to where you might not have to do this, but I like the visual for this. Okay, so remember there's a 2 here. So I'm going to underline the parts I can simplify. I can take the square root of the 25. I can take the square root of x4 and y4. Okay, so those 3 pieces will come out. So on the outside I'll have a 5. Remember you just divide these. 4 divided by 2 is 2. And 4 divided by 2 is 2. So x squared, y squared. What's left on the inside of my square root? 5y. Okay, because in order for it to be a square or come out of the square root, it has to have a pair, and we only have that single y. So you have to be careful here because you do need to check for your special cases. Do you remember your special case from yesterday? It has to be even on the inside and even on the outside. So the only one really we need to look at is x to the 4th. It's even here, and it's even here. But when it came out, was it even or odd? It was even, so it's not a special case. Remember, if it's even and even here, and it comes odd, that's when you put absolute values. I think I only have like 1 like that today, though. Okay, number 7. 54, A3, B7. I did not even touch that. Okay, we're doing cube root. So what of our cubes goes into 54? 8, 27, not 64. 8 or 27? 27 times 2. Yes, good guess. 27 times 2. Okay, I already have 3a's, so I can leave that one. And I'm going to split the b's because 7 is not divisible by 3. So I want to make it an even number that 3 goes into. So b6, and then I'll leave b1. So I'll underline again what's going to actually be able to come out. I can take cube root of 27, cube root of a to the 3rd, and cube root of b to the 6th. So what's going to be on the outside? 3, A, B, B2, and what's on the inside? 2B. Since we were taking an odd root, a cube root, I don't even have to worry about that special case. Let's do one more simplifying one, and then we'll do some adding and subtracting. Oh. It's not bad. Okay, is everyone number 7? Number 8. Okay, so we have a 4th root. So which one of our, I don't know all the fours. 16 times, good, 16 times 3. So I have 3 fourth root, and I'm breaking 48 up into 16 times 3. And then I have 5 x's, so I want to split that up. X, 4, and then 1 left over. And then I can leave y, 8. Is anyone confused what I'm doing here with the variables? Okay. So I can take the fourth root of 16, x4, y8. Okay, now I see a lot of people that will forget this 3 out here. So don't leave it in front. So when I bring out, what's the fourth root of 16? 2. So I bring that 2 out. I bring out how many x's? 1, because it's 4 divided by 4. And how many y's? 2. And then what's left on the inside? 3x. Okay, and then go ahead and multiply. Oh my. Go ahead and multiply these. So our final answer, 6xy squared, fourth root of 3x. Okay, let's double check our special case. So remember, it has to be an even and an even. So the x's don't matter. The y's, I have y8 and y4. And in our answer, we got y squared. So is that a special case? No. It has to be even, and then odd. Okay, adding and subtracting. I only have 3 examples of these because that's how easy they are. Okay. You can only add and subtract like radicals. You can only add and subtract like radicals. And so what that means is the same root. So like it could be a square root, or a cube root and a cube root. Same root, and then same quantity, which is what's under the root. Okay, so the first one, two square root 2 plus 3 square root 2. So this is exactly like if I was adding x's, like 2x plus 3x, that would be 5x. You don't touch the x's. Same thing here. These are exactly the same. So I don't touch the roots. I just add the coefficients in front. So my answer, 5 square root 2. See, that's too easy. It was fine. Okay, number 2. This one's easy too. Number 2. 3 cube root 7 minus 4 cube root 7. So the cube root 7s are the same. So just combine the coefficients. What's 3 minus 4? Negative 1, and then cube root of 7. So the last one, can I combine those? No. Can I simplify those though? Yes, you can. So that's what we just did. So let's simplify these. So I'm going to just write underneath each one because I want to make sure I include these numbers too. So what perfect square is inside 20? 4 times 5, good. So I'm just going to go down the line. 2 times what's inside 45? 9 times 5. And then plus 3. And we already did 81, so what is this one? 16 times 5. Okay, so I'm going to take the square root of 4, which is 2, and pull that out front. I'm going to write out the multiplying so you can see it. The square root of 9, which is 3. And the square root of 16, which is 4. So we get 4 square root 5 minus 6 square root 5 plus 12 square root 5, which is 4 minus 6 plus 12, 10 square root 5. That's really as bad as it gets adding and subtracting right there. Okay, then the last thing is multiplying radicals. Everyone done writing? Okay, multiplying. The last thing okay, so when you multiply radicals, we're going to multiply the coefficients that are in front of the radicals together, and then we're going to multiply under the radicals together. And then we're going to simplify. If you need to. So we'll multiply the coefficients, multiply under the radical, simplify. You can do the other way too. You can simplify first and then multiply, but usually you have to simplify anyways, so I do it this way. Okay, so the first one, we'll just do a couple of small ones. Square root of 3 times square root of 2. So if I was adding or subtracting these, I can't do that, but I can multiply them. Doesn't matter what they are, as long as they're both square roots or both cube roots. So I just multiply underneath. This would be square root of 6. Can I simplify this? No. So just leave it. Number 2, square root of 2 times square root of 2. Square root of 4, which is 2. Alright, let's add some coefficients. So number 3, 2 square root of 3 times 4 square root of 3. So you can multiply coefficients together, and you can multiply radicals together. So if I multiply the coefficients, I get 8. And when I multiply under the radicals, I get 9. Square root of 9 is 3. So my answer is 24. So you don't multiply, you don't distribute like the 2 to the radical. Just the 2 times the 4 and then the 3 times the 3. So just these 2 and then just these 2. Yes. Well, like these 2 didn't have coefficients. So I still can multiply, even if it was like this, without that 2, I would just have 4 square root of 9, which is then 3 and 3 times 4. Okay, number 4. 7 square root of 6 times negative 3 square root of 10. So same thing as number 3, just this one has a multiplication symbol and this one has parentheses. Okay, so multiply the numbers in front. So negative 21. So I multiply the coefficients, and then I multiply it under the radicals. 60. And then simplify. So what perfect square is inside 60?
4 times 15.
Good. 4 times 15. So I bring out square root of 4 is 2, so I bring out that 2. And then multiply. So negative 42 square root 15. Okay, number 5. I just have a few more. So you have two binomials. How do you multiply binomials? FOIL or distribute. So go ahead and do that on that one. So multiply 5 to the 2, which is 10. And then 5 to negative square root 2. So negative 5 square root 2. And then square root of 3 times 2 is just positive 2 square root 3. And then square root 3 times negative square root 2. Careful with your signs. Negative square root 6. Can I simplify anything? No. So that's it. Just an ugly answer. Okay, 2 more. Number, what do we got? 6. There we go. Negative 2 square root 6 times 4. Okay, so instead of two binomials, this is just a single term. So just be careful because some people get confused by the two parts. You're multiplying this whole thing by this term and then by the second term. So I multiply the coefficients, negative 8. And then I multiply it under the radical would be 18. And then I go to the second one, which would be negative 14 square root 30. Can I simplify anything? The 18. What's inside 18? 9. So 9 times 2. Can I simplify the 30? No. So square root of 9 is 3. When it comes out, that gets multiplied. So negative 24 square root 2 minus 14 square root 30. Last one, because we always have to have our variables. So multiply coefficients first, which would be 21. And then multiply the inside. So on the inside, I've got 2 times 6, which is 12. Then I've got 2 x's, I add exponent, so x squared, y squared. And now so we're going to simplify this. So what's a perfect square inside 12? 4, so 3 times 4, and I don't have to do anything with my x squared, y squared. So the square root of 4 is 2. So bring it out and multiply it with the 21. So if this is a 2, I'm dividing. 2 divided by 2 is 1x, and 2 divided by 2 is 1y. What's left on the inside? Should be just a 3. Okay, we have to check our special case. So you always check your special case when you have variables. We had even exponents here and here. We had a 2 here, so even. And what did we get in our answer? Odd. So is this a special case?
Yes.
Yes. And they both get absolute values since they both have odd. And that is our answer. Okay, so your worksheet is going to be for grade, but it's not due till Friday, so hopefully some of my band people can catch up a little bit on that. So the rest of the time is yours.